Hi all. In this video, we will discuss about structured programming in C language. Till now, we have taken many simple programs. Those programs are easily understandable and we can develop those programs without much effort. If you take one large program, how to develop that program? To develop large program directly, it is very difficult. So we have to divide that large program into smaller programs called as elementary parts for better understanding. To develop structured programming in C language, we have to follow top-down design approach. In this approach, first we are concentrating on the developing of main module, later its related sub-modules. That means each module can be further divided into sub-modules. Breaking a complex program or breaking a large program into smaller parts or smaller programs is known as factoring. Here is the hierarchy of modularization. So first we are concentrating on the developing of main module. The main module can be divided into sub-modules. In this example, we are taking module 1, 2 and 3 are the sub-modules of main module. Similarly, you can take sub-modules for module 1, sub-module for module 2, sub-module for module 3. So like that, you can divide your program into different sub-modules. Here we are following top-down design. That means first we are concentrating on the main module, later we are concentrating on the sub-modules. So while dividing into sub-modules, first we have to remember one main thing. Each sub-module has to perform specific task. Like that, we have to divide your program into different sub-modules. Here is the one example for modularization. We are taking one college example for modularization. So here we are taking principal as the main module. So under principal, we have several departments. So one is cultural department, sports department, and academic departments like that. So under cultural department, again we have sub modules. So one is singing, another one is dancing. So all singing related activities we are taking under single singing module, and all dancing related activities we are taking under dance module. That means in each module we are performing one specific task. So like that you can implement modularization in any programming language. So here to implement this modularization in C language, we are using functions topic. To implement modularization or structured programming or top-down design, we use functions in C programming language. A function in a C programming language is a part of the program which is used to perform a specific task. A program in C is made up of one or more functions. Okay, out of these one or more functions, one function is called as main function, where your program execution starts and your program execution ends. This particular main function is called by the operating system. After completion of your program, that control returns to the operating system. Now see the structure chart for a C programming. So here we are following the top-down design approach. First one is we are concentrating on main. These sub functions are called from main. So function 1, function 2 and function 3. Again, these function A, B, C are called by function 1. So whenever function A job is completed, it returns its outputs to the function 1. Whenever total function 1 job is completed, it returns its output to the main function. So this is the structured chart for a C program. As we have taken, a function is a section of program that performs a specific task. So here you are writing functions. Those functions receives 0 or more inputs or more arguments and perform some operation on that data. After that, it returns at most one argument. So that is the basic thing in any user-defined function or system-defined function. Any function receives 0 or more arguments and returns at most one value. Here, if you develop your program, if you do one project by using functions, so there is a possibility of fewer defects. That means number of errors you are going to reduce by using this modular approach to develop the programs. The following are the advantages of functions. So here, programs can be factored into understandable and manageable steps. That means once you divide your program, large program into sub-programs, those sub-programs are easily understandable and you can easily develop code for them. So here, you if you take different functions, many people can work on that particular project, and by working as a team, you can reduce development time for the project. So all those things we can combine to get as a single application. So these functions support to reusability. So that means if you write one code, one sample function, so that function can be used by many functions, many other functions. So this saves time in rewriting the same code. So as we have taken one project is allotted to one team. So many people working on that particular project. So here in this example, James working on inquiry module, Susan working on withdraw module, and George working on deposit module. So you are combining all these things. So we are integrating all those things to get the final application. So to write a function, mainly what you require. We require function definition, function declaration, and function call. So this function definition again, that one contains code for the function. So to what is the job you want to perform on the arguments. To perform that job, you require some code. That code is present in that function definition. So this function definition is made of two parts. So one is function header, next one is function body. So this function body is a compound statement with opening and closing braces. First, we see the function header. So function header, what it contains? So it contains a return type. So what that function is returning, and name of the function, and the parameters list. So those parameters list are called as formal parameters. So in function header, you are not supposed to end that one with a semicolon. So the return type specifies what type of data you are returning from the function. If you are returning integer data, you have to give as your return type as int. If that function is returning floating point variable, then you have to give your return type as a float. If that function is not returning anything, you have to give that return type as a void. Then the function body. So all the executable code you are placing inside the function body. So here each statement terminated end with a semicolon, and at the end of this function body you have to provide a return statement. So what the value it is returning, you have to give that particular variable value. If that function is not returning, so keep that one as empty. So return semicolon. Mainly, we have two types of parameters. First one is formal parameters. Second one is actual parameters. The formal parameters, the parameters which are used in function definition. So these are variables which you are using in the function definition. Those are called as formal parameters or formal arguments. In the function calling, what are the arguments you are using? What are the parameters you are using are called as actual parameters. While giving these formal parameters and actual parameters, the type, order, and number of parameters must match. Otherwise, compiler gives us error. However, there is no need to match names of the formal and actual parameters. Observe in this example the parameters. So we have two types of parameters, formal and actual parameters. Actual parameters are used in function calling. Formal parameters are used in function definition. So observe in this example. So we are calling the function average is our function. So we are calling with two values or two parameters. So these are called as actual parameters. And you are calling this function, control comes here. So 10 is assigned to x, 20 is assigned to y. So now these x and y you are using in function definition. So that's why those are called as formal parameters. After execution, after performing this statement, this function is returning some value. So what is the type of that one? It is returning double. So we have to provide return type as the double. Now we will take function declaration. So it is similar to the function header. So without semicolon, with semicolon and no code. So here in the function declaration, we have to provide what is the return type of that function, then what is the name of the function, what are the argument list. So what is the type we have to provide here, and that one end with a semicolon. So this function declaration is also known as a function prototype. So here, these function declarations, where to keep these function declarations? You have to keep this function declaration before main in global declaration section. So observe this one in function declaration. First, what are providing? Return type. So next one is the name of the function. So all the parameters list, and these are formal parameters, and for each one you have to provide type like that. And this function declaration ends with a semicolon. This function declaration is also called as function prototype. Next we will take function calling. This function call is a postfix expression. So the operand in function called is the function name. The operator in parenthesis set which contains actual parameters. Here the actual parameters are separated by a comma. So once you call one function, control transfers to the function definition. After execution of a function, that function definition returns results. Then control comes to the function calling place. So the functions having a return type void can be used only as a standalone statement. Observe the general form of function calling. So here, name of the function you are providing and the arguments, all the argument names we are providing here and end with a semicolon. So all these arguments are called as actual parameters and these are all separated with a comma. Here is the example for function calling. So here I am calling one function. That function name is multiply. Then I am sending two arguments. One is 6, second one is 7. So those are actual arguments. So this 6 is assigned to x, 7 is assigned to y. So x value becomes 6, y value becomes 7. Then here in this we are performing operation, multiplication operation, return x multiplied by y. So obviously this one returns integer value. So we mentioned a return type as int. Once it returns value, that value comes here. So that one is assigned to product. Like that, when you call one function, control goes to the function definition. After execution of function definition, it returns value. That value comes to the function calling place. If that function definition is not returning any value, anyhow it returns control to the function calling place. See how this function works in a diagrammatic manner. So in from main function, you are calling one function. Once you call, function control goes to the user defined function. After execution of that particular user defined function, that one returns control to the function calling place. So here is the sample program by using functions, okay, to demonstrate functions multiplication of two numbers or a simple program. So first I am taking a function declaration. So what is function declaration contains? What is the return type of that function? Name of the function and formal parameters list. So two arguments I am sending here, in two integer arguments. So I am taking int comma int and function declaration ends with a semicolon. So now see in the main function I am declaring three variables: multiplier, multiplicand and product. Next, I am reading multiplier and multiplicand values. I am calling function. My function with the name is multiply. So here I am using function calling. I am sending two arguments. One is multiplier, second one is multiplicand. So once I call, control goes to the function definition. After the completion of execution of function definition, it returns the value. That value is assigned to the product. Here we are printing the product value. So next slide we will see how to write our function definition. So here once you call this multiply function, control comes to the function definition. So here first value is assigned to the num1 multiplier and multiplicand is assigned to the num2. Here we are performing multiplication of those two values and you are returning this particular integer value. Once you return this value, control goes to function calling place. That value is assigned to the product and that product is you are printing. Observe here, you are sending two values 17 and 21. Product of those two is 357 is printed. So this is the introduction to the functions. Thank you.